you're muted.
Yes. Hello, am I audible now?
Yeah, I hear you now.
Yeah. So what I was saying that this is the second webinar of this series, DESIGNSPIRE. Basically, all of you know, DESIGNSPIRE is the initiative by 𝐀𝐧𝐝𝐫𝐫𝐲 YouTube channel and 𝐀𝐧𝐝𝐫𝐲 Academy. So this year, this is a competition for students and fresh graduates basically in India. And this year the topic is building design. So we have already closed our registrations for this competition on 31st March, and now we are waiting for the submissions from those who have participated. So we have many students in group or in as an individual who have joined in this program from all over the country, from different reputed institutions in India. So as a part of this initiative, DESIGNSPIRE, we are conducting such webinars with the industry leaders and industry experts. So today we have Mr. Timo Harboe Zollner with us. He's a computational design specialist, founder of Timo Harboe apps, and founder of Python for Structural Engineers. It's a learning platform for the structural engineers who are interested in Python, basically how you can implement Python. So I'm also a attendee of this program. It's an amazing program. So I think most of you have joined already, so I won't waste much time, and I would like to request Timo to start the presentation today. Over to you, Timo. Thank you.
Thank you very much, Sandeep. I'm just gonna mute my my speakers here because the beep sound from Teams is coming. So if there's anything, just send the message in the chat here.
Yeah, sure.
That.
One more thing I just want to add before you start to the participants. So any of you, if you have any questions, there is a Q&A option in your screen. So please put your questions in that Q&A option only. We will not be taking any questions in the chat box because it is very difficult to sort out the questions. So we'll be taking those questions which you are submitting through that Q&A option. So and end of the session, we'll be taking those questions that you have, you can say, registered. Thank you. Over to you.
Thank you so much. And thank you everybody for joining. So I just think I first want to tell a little bit about the intention with this presentation. So it's about using Python in structural engineering, or using programming in structural engineering. And everyone, please keep your microphones muted. Just hang on a second. So it's about using Python in structural engineering. It's not about becoming a programmer or in any way, starting a software development career. It's simply about learning how you can use programming to be a better structural engineer. I'm just going to share my screen over here. Do you see my screen now?
Yes, absolutely.
Perfect, thank you.
Yes.
So let me just see if I can get my mouse over here. So first, a little bit about myself. I come with a background as a structural engineer. I have graduated from the Technical University of Denmark. Also spent some time in Singapore and in Munich as part of this degree. And then after I graduated, I started in 𝐵𝗑𝐺𝐻𝐿 Group, the big Danish architecture firm, where I helped them start up their engineering department. Then there it was very natural that, of course, we use programming as part of our just the normal way we work with things. Then a bit later, I came over to Ramble and got a role where I was leading the initiatives to get more automation, more computational design into the buildings department. So I was sitting in the high-rise department designing towers, and that was when it really clicked for me how much you can do with Python in structural engineering. So now I've started my own consultancy, very much focused on automation. So I have Timo Harboe, as you see to the left there, is my consulting company. And then I have my course, Python for Structural Engineers, where I teach structural engineers how to do better work with Python. And I wanted to show you a few of the projects I have worked on and where I have applied these methods. So I've been very lucky to work on some quite beautiful projects, from the City Milan in Milano by 𝐀𝐧𝐝𝐫𝐫𝐀𝐻, to a sculpture at Burning Man Festival, to some like decent size towers in Denmark, and some more like innovative projects. And I've also done like normal residential buildings, normal office buildings, but what they all have in common is that there's been workflows in this where I've used Python again and again and again to deliver a much better project. So what I want to go through here is first to give you a bit of an intro, like why is it that we talk about Python so much? It's something that is really spreading more and more people are talking about it, more and more people are using it in their work. And then I want to show you a lot of practical examples. That's why we're here. We want to see it in use. And it's all going to be semi-live demos. So some things may fail. Most things should work, but let's hope for the best. And then I'm going to give some suggestions to what you should learn and how you can learn it. And then we're going to finish off with some Q&A. So just about myself and my road into Python. So I have known Python since my early study days. Like I used it in different things, have done small little programs, but I actually never used it for work. I was doing fun little things, but it never clicked with me how I could apply it to structural engineering. Then one day I took a course in data science for architecture, engineering, and construction. And that was when I realized that, hey, all we do in structural engineering with our finite element models is big data. We work with big data all the time. And combining data science with finite element models is a complete game changer. So I had this project that I worked on where you see a ETABS model on the left, you see the building under construction to the right. Then unfortunately the plots you see are not from this exact project, but they are a similar thing that we did. Essentially, my boss asked me that every time we did an iteration, I had to output the same plots so we could really keep track of how the building changed performance through the project. And we had an Excel template where I could sit and copy paste data manually around, and it took forever. Then I ended up writing a Python script, and it was one click suddenly every time we had a change. A complete game changer for the workflow. Meant we could iterate faster, get better results, and just a lot more fun as well. So I want to reiterate this, that it's not about becoming a programmer. It's about becoming a better engineer. And it's about spending less time on doing boring stuff. Like a lot of the time we sit and copy paste data around. We type a lot of stuff in Excel. We do a lot of work that does not necessarily require our engineering skills. A lot of data handling, a lot of repetition, that Python is better at than us. So my intention with this is to show you how you can take control of your computer and get the full potential out of it. So a lot of the time when I talk with engineers about Python, they say that, hey, we are like we don't program. We're not programming. I like Excel, but all that code is scary. And then they show me the templates that they use, and then you have Excel code that looks like this here, which most engineers are completely fine about because it's an Excel. But this code here could also be written like this over here. So these two pieces of code, they do the exact same thing. But I would argue that this over here to the left is both easier to write, to read, and to quality control. This is not me saying that Python is better than Excel, but I say that there are some things we currently do in Excel where Excel is definitely not the right tool for the job. A lot of the time. Another thing that I've often seen is that we have a lot of old Excel templates in the different companies that we work in, and you may not want to sit and translate all of those to Python. But the good thing about Python is we can get it to do pretty much whatever we want. Any idea you may have is something you can most likely implement. So if you have an old Excel template that you need to use because it's been QA'd, used for the last 20 years, well, then you can use Python to inject data into it and automatically extract data from it again. So a key summary here, Python is easy to read, it's easy to QA. It has a very simple syntax. Compared to a lot of other programming languages, Python is, I would say, by far the easiest to write. It integrates quite nicely with Excel and spreadsheet data. And then, similar to all other programming languages, it can be broken down in modules. So if you've written a little script at one time, you can just reuse it again and again. Which is something, if you have a little smart function in Excel somewhere, it's quite difficult to reuse it elsewhere. But with code, that's a lot easier. There are lots of external libraries, like a lot, and they're being downloaded 1 million times a day, and they are being maintained by the most amazing people in the open source community. So you have a lot of resources available. You're no longer relying on the developers of Microsoft, but you are having a ton of the developers developing amazing tools for you. It's the fastest growing language in 2024. Jupyter notebooks, where you write Python in, are going absolutely crazy in like how they increase in use. And for example, the Technical University of Denmark and other universities as well, now all students learn Python. It's something that every new student comes out with is Python knowledge. So I'm not just saying it's cool, a lot of people agree with me. Then this one is also one I want to reiterate a little bit, that it's not so much about learning how to use a new tool. Of course, you have to learn how to use Python, but the real power is when you get to work with your existing tools and your computer in a much smarter way. So yeah, you learn a new tool that enables you to work better with your existing tools. Let's get to some examples. So now, I'm just going to close this one here. Wait a second, we're going to stop sharing and put this one away. I'm going to start sharing again. So now you should be seeing my screen. Please shout if you don't. So what I'm going to be doing now is I'm going to pull things in and out of the screen, different examples that we're going to run, different pieces of code. But the very first thing I want to show you is what code can look like and how easy it is to write it. So let me open a browser here. So now I've gone into Google Colab. So colab.research.google.com. It's a free service provided by Google that enables you to write Python code without installing anything on your computer, and it's free. You don't have to pay anything. And when you come in here, it essentially looks a little bit like a Word document, and that's these Jupyter notebooks. So here you can, this is not code, this is just, markdown language. So you can say title, this is my header, and then you have edited the document. You can also put math formulas, pictures, whatever you want in here. But the real power comes when you start writing the code. So here, just to show you some super simple Python, we say that we have a variable a is equal to 200 meters squared. We say as a comment to it. Everything that's green is a comment, not part of the code. And we say that we have a load of 5 kPa, and then say total load is equal a times load, and we can print the total load. This is pretty simple stuff. But then what we can also do is to take what we had here, like this total load calculation, and we can save it in a function that we can use later. Very, very simple calculation, but we define a calculation, calculate total load that takes an area and load as input and returns area times load to us. So now whenever I am somewhere and I want to calculate the total load, I can just call this function. So now you can imagine more complex functions such as calculate the capacity of this beam, or calculate the required reinforcement, calculate the stiffness of this. You can write functions and reuse them without having to write all the code again. And when we write this here, we get what we expect. An area of 300 times the load of 5 kPa gives us a total load of 1,500. And one of the really cool things about Python is, or programming in general, is the ability to loop over values. So in Excel, you have the possibility, unless you do a row-based script, then you put in one value, everything calculates, and then if you want to try another value, well, then you type another value and see what then happens. But if you have to do 100 different values, it gets really time-consuming. Here, you can simply just make a list of the values you want to check. In this case, we want to check the loads 2.5, 4, and 5. And we say calculate all of this here for every value in that list. So we see first we get 500 out, then 800, then 1,000. So that's probably about the quickest introduction to programming that you can get. So the key message is here that we can reuse code and that we can loop over values to perform the same operation again and again on different values. Let me show you some practical examples of this here that we can actually use for something. I said that this is about using your computer as well. Like any idea you may have that you think, hey, this could be pretty cool. Can my computer do that? The answer is probably yes, it can. So let's say that your project manager has asked you to every Friday just send him a list of all the files inside a folder, and he would really like you to check what files have been changed in the last 30 days and give you a list of those as well. And you can quickly imagine that that's quickly some hours gone on a Friday afternoon. So I tried to give this suggestion to ChatGPT, which I use a lot and that we're going to be talking about a lot here. Both the good and the bads about it. But let's start with the goods. So I suggested to ChatGPT that I would like to write a script that extracts a nested folder structure of a folder and opens an email with the file list. And then I go through a little bit more iterations of this. Like you can see, every time I'm out here, I'm asking it something, I get some code back. We talk a bit back and forth. So the code I'm going to show you now is actually something that I wrote in collaboration with AI. So we have it here. I have this piece of code here. Run it. I trust it. Let me just run it here. And then on my other screen over here, just popped up a mail. So I have now to the project manager at the company I work for.com. I gave it the subject, folder overview, recent changes plus structure. Here are all the files in that folder structure that has been changed in the last 30 days. These two are the interesting ones. And here is a list with the full nested file structure in that folder. Now you may say, oh, yeah, but you don't need to do this, but maybe you need to do a drawings list at some point. Maybe you need to gather a list of site images or something else that you can think of. So this is a really, really useful thing if you need to do this again and again. Then, and another thing that I like using Python for is calculation templates. So let me open this one here. I just have something to drink. So, as I said, you can make these documents here look very much like a Word document. A Word document with code in it, essentially. The benefit of this is that it's very easy to provide explanations. It's very easy to to make your code readable for other people. It doesn't become this like looking like the matrix on a black background and everything. It's very user-friendly. So here you have explanations, and all these gray cells is where we run some code. So we have some geometry of a beam. We have some material properties. We have some rebar, design factors, loads. And now you can see we start putting in these mathematical formulas here, just to show clearly what formulas it is we're using. We can put in our diagrams, again, more complicated formulas. So this here becomes incredibly easy for other people to quality control. And what I also like about this is that compared to an Excel cell that is hidden until you click on it, here all the code is out in the open. So it becomes extremely transparent if there are any errors in the underlying formulas you're using. So let's try to run this here. So now we have run all the code, and I just want to get down to the fun part down here in the bottom. So we talked about this with looping, and now we have a calculation template here where we can calculate the capacity of a beam. But often you may want to calculate the capacity of the beam under different reinforcement layouts or under different circumstances. And that's where we can put all of this beam calculation into a function and loop over it and perform a calculation again and again. So let's say that we just want to check the capacity of the beam for different sizes of rebar, like for these diameters. And for the sake of simplicity, we just put 3 bars in the bottom. Then we call this function we've written here to calculate the beam capacity. We run it. And then you can see that if we use 3 number 8 bars, utilization is to 277%. And we actually have to get down to 3 number 16 bars before we get the utilization under 100%. So this is a quick way to check how different reinforcement layouts perform. But what could also be interesting would be to see that if we use different size bars, how many would we need to satisfy the criteria for the beam? So down here, we do the same thing. We loop over each bar diameter. So we check first for 8 millimeters, then for 10 millimeters, then for 12 millimeters. And then we keep increasing the number of bars until we are at 100% utilization. And then we give the user the result. So we run this code here. And you can see for 8 bars, we need 9 pieces to get 92% utilization. For 10 bars, we need 6, 12 bars, we need 4, 16 bars, we need 3, and so on. So we have just written an optimization algorithm here. So now you can go to your boss and say, hey, actually, we can use either 4 number 12 bars, or we can just put 3 number 16 bars in. Like you have all the options available here. So really, really quite useful. Something that you may not like in this is that when you're up here, you write everything in like in the units that they have, like 450. What is that? Like you have to be very explicit about this being millimeters. Otherwise, there's no way of knowing. So I say depth in millimeters is 450, but we would actually be like to know, we would be able to know. We would like to be able to know that it's millimeters. So there is a really amazing guy, Connor Förster, who has developed 2 packages to help us. So again, open source community, people developing amazing tools. He has developed hand calcs and for all people. So let's look at the same template again, but this time where we integrate these 2 free-to-use plugins. For all people allows us to work with units. So now I can, instead of saying shear force in kilonewton, I can say 300 kilonewton. And I can then also say, I for example have here 300 kilonewton. I have 5 meters. Then I get a result of 1.5 meganewton meter as a moment. So we can work with units now. And what is also really cool is that you can render these calculations. So now actually let's go down a little bit here. Here we have the same calculation as before, but now it's written out like this, also with comments. So you can actually print this and give it to whoever has to QA it and it becomes extremely readable and transparent to go through. Another thing, let me just open, I think I need to go back to my slideshow. Hang on one second. I am just quickly changing around here. Sorry about that. Here we are. So I worked on this project here in Copenhagen. It was a new headquarters for the 𝐾𝐩𝐩 group. And there we have these massive floor spans, and we had to do vibration analysis of the floors. And we were writing a report about these vibrations, and it was a really beautiful report, like nicely set up, easy to read. And then I had to put in a plot like this one here, and I looked in this 𝐀𝐧𝐝𝐫 𝐀𝐩𝐻 British guideline for vibration, and I needed this plot out here. And what I wanted to do was to then show where our curve for our building was, like our requirement, and put in some test points. And how engineers would normally do it is they would take a screenshot of this horrible looking grainy plot here, and in Paint or PowerPoint or something, put some new points in. But I wanted to do something that looked better and that was reusable as well. So I wrote a little script, very similar to the one you see here, where I also put in all the formulas, so you can actually, it's very easy to read for other people. Let me just run the script here. So I take in the formulas that generate the plot, and then first I get this plot here, needs a bit of love. Then I get down here, and here you can see you have suddenly a very high quality image. I have put in my limit here, and I can also put in the points, like my data points. I could actually put in all data points I have for like thousands of points I may have in the building, and automatically plot them on here. Here I've just put in 5 points. But suddenly I have a template that I can reuse on every single project that we do vibration analysis on. It looks a lot better. It's faster when you have made it. And yeah, it's also a lot more fun. Then I had another project, this one here, where I worked, that was when I worked in Ramble together with Henning Larsen, where we worked on a floor solution where we would have these, what they call like thin ground floor slab on top of styrofoam, essentially. And that is a really interesting static system. It's very similar to what you have here. Just put this one over. Very similar to this one here. So you have a beam and springs. In our case, it was a little bit more complex because it was not just a steel beam, it was a concrete slab that can crack, and it spans in 2 directions, and reinforcement is in 2 different layers. So it got more complex than just this here. But the idea is that when you decrease the stiffness of the beam, then you have springs under the force becoming more utilized. So we wanted to optimize the thickness of this slab just enough so that we don't damage the styrofoam underneath. And that's where we need to test for a lot of different thicknesses, and for some variation in the spring stiffnesses as well. And here we can also use Python. So here I'm maybe doing a bit of an overkill, but I'm defining this finite element model inside this Jupyter notebook. So here I'm defining the model with text. I'm writing where all my notes are. So I'm not importing anything. I'm not using any external FE software. I'm doing everything in here and doing a nonlinear analysis. So let's get down here to the bottom. I really like these 2 plots here. So here we check what happens when we decrease or increase the stiffness of the beam. What happens to the reaction forces in the styrofoam underneath? And you can see if we have a very low stiffness beam, we have a very high peak force in one point, and the stiffer the beam gets, the lower that peak force gets. And you can see it's a nonlinear analysis because the springs are only compression springs. So you get also these kind of intuitive but fun-looking deflection plots here. So yeah, you can do finite element analysis in Python as well. I would probably recommend in most cases that you link Python to the FE software that you use, because then it's you don't need to write your model manually like I did here. Then you have another situation which I've experienced in pretty much every single project I worked on, and that is that you have some errors in your models. And that could be, for example, here, where everything looks fine, but you come over here and you see that, hey, actually this column is not connected to the slab. Or like small little variations that you think, hey, there's something wrong. You see it when you run your model, but what if all your columns are just a little bit off? It's quite a time-consuming process to solve. A really simple thing to do is to export the model as a text file. So I'm going to show you an example from a robot where we can export the model as a text file, do some changes to the text file, and then regenerate the FE model from that text file again. So let's say we have this text file here from robot. This is our entire finite element model, a very tiny one. And here we have our nodes, our node coordinates. And you can see we have some values that are a bit weird, like here 0.009, we have 5.011. We have some values that are nearly round, but they're not really round. So what I would like would be to define some grid lines. And if a point is close to a grid line, but not exactly on it, I just want to move it to the grid line. So if a point is like 10 millimeters from a grid line, then move it to the grid line, or at least show me where it is so I can change it myself. So for this here, I wrote a little script. Gonna find it here. So these are actually, now I gotta see the solution to an exercise in the course. There are a lot of exercises, as you can see. So here, I say if and only if a point is within 0.1 meter of the grid line, move it to be in that grid line. Report to the user the distance that you have moved the point. So I define some grid lines here, pure X, Y, and Z heights to keep things simple. Then I go through this text file and I see if they're close, exchange them. So I run this code here. And I can then go out my folder. And now I have an updated file here. You can see if I put them next to each other, you kind of see the change. You can see for my X, these first values haven't been changed because I did not have a grid line at -8. So these remain unchanged, but all the other values here have been rounded to the nearest grid line value. If I put in here -8, then, and I took away this 3, for example, and just closed this again, if I'm allowed. Close window. Now run it again. Then with a bit of luck, just need to make sure I save it in the right folder. Bit of luck, we should have it here. Now it's rounded to this value here. And the 3 value is no longer rounded. So it works as we expect it to. So let me show the next example. So this project here, a beautiful tower in Denmark as well. And here I worked a lot on the foundation design of this building here. What I'm going to show you now is not from this project, but it's a similar problem that I experienced in this project. So let me just quickly see. Yes, it's here. So we had this, okay, say not a problem, but we had this situation that we needed to iterate a lot on the spring stiffnesses in this project. So we provide some reactions to the geotechnical designers. They come back with some spring stiffnesses. We run the models again, give some information back to the geotechnical guys. We get some information back. And so we ping pong back and forth every single week for a long time until we have reached the final spring stiffness values. And I don't like to do that kind of work manually. So let me show you how that can be approached. So let's say that you receive an Excel sheet from your geotechnical engineers. You may have agreed on them on the format, or they at least have to send it in the same format every time. So in this case, we've received an Excel sheet that looks like this. Pile number 3, new pile stiffness this. Pile number 5, new pile stiffness this, etc. Then now what you see here is a very long notebook because I explain everything very thoroughly in it. But if you condense the code, it's not very long. So I now again export my model as a text file. So this is for 𝐀𝐧𝐝𝐫𝐶. So I export my 𝐀𝐧𝐝𝐶 model as an E2K file. And now I want to go in and I want to look for for spring number. What was it? Spring number 3. And I want to see if there's a spring property for this pile number. And then I want to give it this value here. So I'm basically just going through this list, looking for these values in my 𝐀𝐧𝐝𝐶 text file and exchanging this information. So if we go down to points, actually we need to go down to point. Oh, no, I have to be careful here. Point assigned. Then you can see we come down here where we assign properties to the joints. And you can see in this file we actually only have one spring type. We have spring type A everywhere. I think, yes, spring type A, spring type A. So we just have one spring for our whole building. Now we run the script. So I'm not going to go through it line by line, but we run it. I already did that before here. And then what I get out afterwards is a new E2K file. And everything I've changed in here is the spring stiffnesses of those exact springs. So if I now go down to point assigned, you'll see that now I have created a new spring for each point. So number 91 has spring type 91. I go down here, point 240 now has spring type 240, 242 has spring type 242. And if we just look for spring type 242, for example, you can see we come down here, and here we have all the new spring stiffnesses defined, fully automatic. So now every time that your technical engineer comes with a new value, I just run the script and I have the new spring stiffnesses in. It's going to take me less than 2 minutes to update. So let me show you another example. Similar example. This one here was a project I also did in Denmark. And here we had to do a lot of sensitivity analysis. So what happens if our ground slab is a little bit thinner, if it's a little bit thicker? What happens if we decrease the walls of the core? What happens if we do something with the materials in the column? Like, we wanted to really optimize it. And we did a lot of different testing of different models. And it was always the same plots, always the same things we wanted to check. So, for example, the periods of the building, the distribution of forces. The difficult thing here is that you have 2 finite element models, and you need to compare the metrics of each model with each other. And what I did when I first did this, I can just see I have been frozen over there. Sandip, can you please confirm that you can still hear and see what I'm showing here?
Timo, your screen is visible. Just your video got stuck.
Okay, perfect, perfect.
Yeah.
Hi again. I think I just lost connection.
Hi, Timo. I was actually trying to connect with you, but I couldn't manage to connect. Yeah.
No problem. But yeah,
Yeah, you can share the screen now, I guess.
yeah, but I think so. Did you get the last? Did you see the last part of the presentation with the QA stuff?
No. Actually, after you have messaged that, I've messaged you that your video got stuck. After that, we couldn't manage to see anything from your side. You just got disconnected.
Oh, so
So
when did did you hear about the learning path?
no. We got disconnected when you were showing that project about that pile and the foundation part.
Oh no! Oh no!
I think you are continuing. I was thinking that you are continuing the session and
Yeah. Like I've been presenting for you for the last 10 minutes, I think. Sorry about that.
No problem.
But then there is just one thing I'll very quickly show you.
Yes.
So what I was presenting before was that all the examples I've shown here is something that you will be able to do yourself if you learn the things that are on this very slide here. You need to learn some Python fundamentals. We'll say if you study for about 2 weeks, about 6 hours per week, you will be able to get a good grasp of Python fundamentals. And then you need to learn some matplotlib. You need to learn some pandas to be able to work with these big data, work with your spreadsheet data. And you need to learn about the OS module. So this here is the 4 fundamental things I would say you would need to start learning to be able to really use Python effectively as a structural engineer. Then, due to time, I don't think I'm going to go a lot into depth with AI again. But what I wanted to say here was that I use AI a lot, but one has to be quite careful with how you use it. So I would say a few tips for how you can use the AI is that you use incremental prompts. Like don't try to solve a whole problem with one prompt. Small steps, refine step by step. Ask for explanations. Like if there's some code that you don't really understand, that get it to clarify how and why it works. And focus very much on your data structure. So what is the input to something? Like if you calculate the capacity of a beam, what are the inputs to that capacity check? It's your reinforcement, it's your material grade, it's your load, not your loads, the dimension of the beams. And your output is a capacity. And then you can get AI to kind of help fill in the blanks, but you need to be able to define what you have and what you want. And the most precise way to describe a solution to a problem is with code. It's very difficult to describe something precise with human words. Our standards of engineering standards use like if this, then that, if something else, then this. Like very precise definitions. And that's also why it can be difficult to actually program with prompting. Because human language is not as precise as code. But what you have to worry about is the logic. The syntax used to be a huge problem with writing code, that you would spend hours and hours getting the syntax right, like how you exactly write it. But that's not the case anymore. Now, with AI being here, your key worry is getting the logic down and let AI help with the syntax. And yes, my course, I have a course where you can also learn all these things I described right here. And it's about 6 weeks of studying, like 6 weeks, quite intense. I say 6 hours per week. And the enrollment opens in about 2 weeks' time on the 18th of April. And it's lifetime access. It's self-paced, so you can do it when it works for you. If you don't want to spend 6 weeks, you want to spend 12 instead, you can do that. You want to take a break in between, you can do that. You're not fully satisfied within the first month, you get your money back. And I just want to say, it's €399 for this access. And you can sign up on the waiting list for it. We're around 5,000 something people signed up on the waiting list on Python for structural engineers.com. And I think that now brings us to Q&A. And sorry about losing the connection before. I hope that not too many of you left because of that.
Thank you so much, Timo. It was a great session. Just for a while we lost you, but most of the thing you have covered in the first part of the session only. So I think we have few Q&A, questions. If you see in the Q&A section, I think you can also have a look, right, Timo, from your side?
Yes, I can. Yeah. So maybe I start at the bottom with the oldest questions. Will the recording be shared afterwards in case I need to leave early? Sandeep?
Yeah, yes. The recording will be available in our website, 𝐀𝐧𝐝𝐫𝐶.in, and also in our YouTube channel. Yeah.
Then there's another good question here. Where are you running your scripts? Is it VB? I am running the scripts, like here I've run them in something called Visual Studio Code. You can run pretty much all the scripts I've shown here also on Google Colab, so in your web browser. And some people use JupyterLab, other people use it's called IDEs. So there's a lot of ways you can run these scripts. The easiest way to get started is to go to Google Colab in your browser and start playing with it. The course, the next question from Laval. The course is €399. And I also want to say that, of course, I would love to have you on the course. There is also other possibilities to learn. You can always learn a lot about Python online. What I felt was missing online was something that directly connected structural engineering with Python, which is why I put a lot of effort into creating a very niche course for structural engineers. If you learn it online, you will have to make that connection yourself, of course. Afsan, can someone tell why the speaker is not speaking? Sorry about that. Taban, you write, in your course, do you cover some applications or practical examples where you use Python and structural software API to automate your modeling and post-processing of results? For someone who already, that's the first one. I cover a lot of practical examples, like it's all about practical applications and practical examples. That's what the course is built up on, I would say. I do not use structural software API. I have been contemplating a lot about whether or not I should do that, but I also wanted to keep the course software independent. So when you have been through the course, you definitely have the ability to learn how to use APIs, but it's not part of the course. So it's something you would have to learn afterwards. And for people who don't know what an API is the possibility to connect directly to your software. So you don't need to export any Excel sheets or anything. You just click and it automatically taps into your software. You can control, for example, eTabs from Python. I've done this a fair bit myself. But yeah, honestly, sometimes I really like it better to export the data sheets manually as well, because then I have the Excel sheet there. My colleagues can have access to it, and it becomes a little bit less of a black box, which I kind of like. Your second question is that for someone who already possesses a solid background of Python, will I be able to just skip the intro to Python and just dive into action? Yes, there are two ways to do that. One is that you simply just like skip complete. The other way is you say, Timo, I know all of this. Can you just mark it as complete for me? And I will do that. So yes, no problem. Then let me see. Is there any computer science fundamental knowledge required for the course? No. I have tried to keep the course quite independent of any necessary computer science fundamental. So this is something that if you plan on going like software development route with Python, then you need your computer science fundamentals. If you're just going to use it in a pragmatic way for your engineering day-to-day life, you will never need it. There's one thing I cover in the course, and that is something about numerical precision. That is that in your computer, numbers are not always precisely defined. Like if you write 0.1, your computer actually reads it as 0.1, 0, 0, 0, 0, 0, 0, 0, a lot of zeros, and then some other digits, which is something that's quite important to understand. But all other computer science fundamentals is not something that is needed, nor is covered.
I think we'll be taking our last question, Timo.
Yes.
Last question from Mr. Nazir, if you see.
Yeah. Daf asks, good evening. My question is, how can we incorporate sensitivity analysis of structural members using Python? Some parameters influence the science of finding that parameter particular research. Is there, so does this code include this thing? I would say no. The engineering wisdom that you have to apply to find out what are the parameters you should do sensitivity analysis on, like to actually have that engineering understanding is on you. What the course helps you with is how can you use Python to combine the results of all your models and compare them to each other in a good way. So it takes care of all the practical stuff around it, but the engineering aspect of it doesn't.
So I think we are at the end of our session. Am I audible? Hello?
Yeah.
Yeah, okay. So yeah, Mr. Shehbaz Khan, do you have any question?
Oh yes, already recorded lectures are available because we don't get full time to attend your lecture. I have a lot of YouTube videos and I'm gonna post some more soon. They're in the same format as in the course. I also see that Venkat writes, is this course limited with already existing modules uploaded in it? Or else any additional videos expected? No. I don't expect a lot to be added to it over time. Like I'm adding a few extra videos now, and I may add some more or change things along the way, but it's not something that's going to keep growing. I'm going to keep growing it until I feel that everything that people requests that is needed there is there, but I also don't want it to grow too massively. But it's going to keep being updated, and for lifetime validity, you get access to all that.
So I think we can close the Q&A session here. And
Yes.
If you guys have any question, you can always you can say connect with us. You can visit our you can say websites, and we are available through LinkedIn, and I have different social media platforms. So if you have any doubt, you can ask. I will try to send it to Timo so that we can get the you can say answers from him. So thank you so much, Timo, for this session. It was really an
Thank you,
amazing
Sanjay.
session. It's a good insight for all of us who are just trying to get into this stuff of Python. And thank you so much to everyone who have joined in this session. This is a great session, and we'll expect all of you to attend our sessions like this. And we'll expect from Timo also more such sessions in different platforms, and obviously in our platform as well. Thank you so much, and good night, everyone.
Thank you very much, Sanjay.
Bye-bye. Bye-bye.
Bye.